Hello everyone. So today I'm going to show you how to convert a blueprint project into C++. So actually there are many advantages of using C++ over blueprint, in not just in terms of performance, but also there are other reasons like maintaining a pipeline that is easier to work with collaboratively with a larger team, things like that. But I'm not going to go into that details. I just want to show you, like, let's first create this third person project which is already in blueprint, and let's convert it to C++ just to see how it happens. How can we do it? So let's select third person. Next, here I'll leave it blueprint because I want to create it in C++. So I'll name this CPP TPS. Sorry, not TPS, TP, third person. Create project. Alright, so here is the usual third person template which works as it intended to. So okay, everything is good. Right, so first, in order to convert this to C++, what we can do is here. So if I open the third person character, you can see the parent class is character. So this is a subclass of character class, and the logic, everything is written in blueprints here. Movement logic and look around, and basically that's it, nothing much, and jumping. So let's see how to convert these, how to write these logics in C++ instead of blueprint. So first I'll add a new C++ class. I'll select character as the parent type because this third person character is also a child of character class. I'll name it CPP third person. Character. Okay, create class. Now you can see the compiling C++ code. This may take some time, not too long. Right, compilation complete, and it automatically opens the Visual Studio project because I have set Visual Studio as the code editor for Unreal Engine. So that is what going to open here. So if you have used something like Visual Studio Code or Rider, that relevant program will start. Right, now this is our CPP third person character. Okay, so here as you can see, just like in this the blueprint, well, actually I don't see the tick or begin play here. We have construction script, so we have begin play here and tick here. So this is the C++ class, and this is the header file. In the header file we have defined what are the methods and other variables or components going to be, and here we usually do the implementation. Right, and as you can see, this CPP third person character is extended from a character, which is the character class of Unreal Gameplay Framework. So now let's go to this third person character, which is this one, and I'll go to class settings, and I'll set the parent class to CPP third person character. Now this is, since this is also a child class of character, we wouldn't have any problems. So let me do that. Okay, now see, everything is same, nothing is changed. And if I play, everything is working as it was before, because even though we have created the new class and assigned this one as the parent class, this is essentially same as the character class, because we haven't overridden any of the functions or modified any of the variables or added any new stuff yet. Right, so the first thing we need to do is let's see, in the construction script we don't have anything, so we don't need to do anything about that. First thing is we have this movement input, move forward and move right. So if I just disable these here, character will not be able to move. See, now I am pressing WSAD, nothing happens. And you should already know these inputs are defined in the project settings under axis mappings. Movement inputs are move forward, move right. These are in the axis mappings. Here we have keyboard inputs and also controller inputs and wave inputs as well. Right, so after disconnecting this, these things are not working now. So let's re-implement the same thing in our C++ class. And as you can see here, this any of these axis inputs, we just get a float value as input parameter. So here under header file in the, I define a private section because I need any other classes who has a reference to this class to call any of those movement input events. So here void move forward float axis value. Right, and another one void move right float axis. Usually in Unreal we use first letter capital in functions and variable names. Right, when you, after you type this, you see here this IntelliSense operation in progress. So this sort of update the references and everything. So after that, if you right click here, go to quick actions and you can create declaration or definition. So if I click on that, I get this because IntelliSense are updating. So now what you can see here is Visual Studio generate a function definition for this function I just created here in the C++ class. So if I press ESC, that closes. So here you can see the function definition, and I'll do the same to the move right as well. Okay, so now in the C++ class I have two function definitions for move right and move forward. So here we need to implement the same thing we have done in the blueprint, which is add movement input. So the way we do this in C++ is add movement input. Here when you start typing the parenthesis, you get what you need here, f vector word direction. So this is move forward, so that means we need as the direction we need the forward vector of the character. So get forward vector, and value is axis value. Right, similarly here add movement input, get here move right, so get right vector. So along this direction we are adding a movement input. That's basically what we are doing here, same as in the blueprints. Axis value. If we need a multiplier or something for this axis value, we can just multiply and 5, or maybe you can just add another variable as well, but for now I'll just keep it like this, simple. So right now, just because we have implemented this function, that does not mean it is automatically identified as the move forward and move right and automatically bound to the input events. We have to do that. So how do we do that? Like this, in the begin play, actually it would be better if we define a separate event to set up inputs. So I'll add a new function, find inputs. Right, now we get this quick action, find inputs. Okay, right, now it is implemented here. So now here let's set up oh wait, the way I did is wrong, because we need a reference to player input component in order to bind inputs. So what we have to do is, there is yeah, it is already there, I forgot about that, set up player input component. So we can implement this function, and this function is overriding from the base class, which is character class. So here we have the implementation for us. So here we already have a reference to player input component. So player input component, this is a pointer, so therefore we have to use this what is symbol called, this arrow symbol, find axis. Now we need to give axis name. Actually there are two overloaded methods here, the same name, bind axis, f name, axis name, and then the user class, and then the function reference. So axis name should be a text move forward. Make sure the letters are same as this. Let me just copy, move forward, otherwise it won't work. And the next we need the reference to the object that we are trying to bind this input. So that means this object. So this means a reference to the current instance of this CPP third person character class. So using this we can access the current reference, current object reference. And the address of the function that we need to bind this move forward input is, for address we have to use an sign, we have to use this fully qualified name, which is CPP third person character colon move forward. Right, so we are not here, we are not calling the function, therefore we don't need this parenthesis and pass the parameter. We just need the name of the function, so you can define it like this. Similarly, input component bind axis. So this time we are going to bind move right. Object is this, and C++ CPP third person character colon move right. Okay, now let me go ahead and compile. I have enabled auto saving, so I don't need to save, but if you want, if you haven't, you can just save all with this button. So compilation complete. Now you can see the character is moving. Oh wait, here I made a mistake. So move forward is working without move forward is working, but move backward is not working as intended. Move right is also not working as it used to before. So the reason is, here we are using control rotation, and from that we create forward vector and right vector. But here what I did is, actually I only used get move forward, get actor forward vector and get actor right vector. That is wrong, but anyway, input binding is working now, so we can just fix this. So in Unreal we have this 𝐂𝐚𝐧𝐧 math library, get right vector, and also similarly a get forward vector, which is defined in the source code engine, this 𝐒𝐻 math library.h. So let's include that. Let me just copy this in and include here. So now we can use now let's create f vector forward equals 𝐂𝐻 math library get forward vector. Here we need an input rotation, so get control rotation. So actually in the blueprint version we are only considering the yaw as the control rotation. So what we can do is instead of giving the get control rotation, we can create a f rotator and here we have to give in pitch should be 0, and then yaw 0.f, and then yaw 8. Yeah, it should be fine. And get control rotation yaw, and again 0, because roll also needs to be 0. Right, then here as the direction I'll set forward. Let me compile. now characters move forward, axis is working properly, move right is not working. Now let's quickly fix that too. So here, same as we did for move forward, I create a vector right equals your 𝐒𝐻𝐵 library get right vector, and we need the input rotation f rotator so 0 get control rotation yaw and 0, and instead of get vector right vector, I'll give right. Okay, compile. Okay, cool. Now movement is properly working. We can move right, move forward without any issue. Right, so I can then get rid of this part. Okay, the next part is mouse input. Mouse input. So here what we do is add controller yaw input and add controller pitch input. Same as before, I'll define two functions in C++, turn and lookup. So let's go to the header file, highlight a comment here, movement input, mouse inputs, right, void, what's the name, what are the names, turn and lookup. Turn, float, axis value, void, look up, float, axis value. Right. Okay, I got this marker, create definition. Okay, create definition for both functions. Now let's go to the implementation. So same as in the blueprint, add controller yaw input and add controller pitch input. Let's try that. Add controller yaw input, value axis value, and add controller pitch input axis value. Now let's bind these two events to functions to player input component, bind axis text input names, lookup and turn. Sorry, turn is defined in first, so I'll add it first. This address of CPP third person character : turn. Similarly, where input component, find axis, text, turn. This, sorry, not turn, look up. This address of ACPP, third person character, look up. Right, now that part also should be fine. First, let me disconnect this. Right, now if the mouse input is working, that means our C++ code is working. Cool. Now I'll delete the mouse input as well. So now we have gamepad input, reset VR item. I'm not going to look into that. Touch input also, that's not important here. Jump. So jump is an action, not an axis. So we have the action here, jump. So here I'll define a function, void jump. Actually by default, that means we already have a function named jump that is already in the character, but actually that is what is being called here, jump and stop jumping. So as you can see here, they are coming from character, target is character. So yeah, let's not define it here. So we can directly call player input component find action text jump so here we need to give action name and key event. Key event means should we bind this function to the on key pressed or on key released, because for an input action we have two states, pressed or released. So here we can give input event colon input event pressed. So that's the event I am going to use, and the class reference, object reference is this, and the function reference is at at a character, which is the parent class of this function, this class, and jump. Right. Okay, similarly let me make a copy, jump, and when this is released, IA released, I'll call, instead of jump, stop jumping, same as we have done in the blueprint. So now let me disconnect these and compile. Right, see, jumping is also working. Cool. Now we can delete this part too, and on the only remaining part is turn right and look up right. So these functions, this event all do the same thing, so the lookup and turning, but the reason that they are multiplied with the word delta seconds is that if we don't have that, the turn rate that comes from the controller will be FPS dependent. That means in a faster computer we will be turning left and right very fast, but in a slower computer that would be slow. But that's not the case with mouse, because when we move mouse left and right or forward or backward, if the frame rate is faster, that would only give us a reduced amount of the movement in the mouse. So therefore the axis value would be automatically adjusted even if the frame rate is different. So but that's not the case for controller, because if we have, let's say if I have pulled left thumbstick, no matter the FPS, when the system checks what's the value of the left thumbstick, it would be either +1 or -1, or depending on the direction that I have pulled the thumbstick. So that depends on the frame rate. So let's implement this same logic in C++. Yeah. Now you may wonder why that was not a concern for movement inputs, because for movement inputs we are using WSAD keys. So for a key, either value should be 1 or -1, or if we are pressed it will be 1, if we haven't pressed it would be 0. So that would be just same as for the controller, but controller we have an analog value, but that's not a problem. But a key behaves very much as the same way of a controller input. So right now here gamepad look inputs void turn rate for axis value void look up rate float axis value. Right, now here what we have to do is same as here, add yaw input and add pitch input, but multiplied with a base turn rate and a base lookup rate. What are the values here? 45. Okay, but these variables are defined in blueprint, so let me change this variable name for a moment, because just to avoid confusion, and I am going to define those variables here and private. Well, I don't really see a requirement for them to be public, but here float. Wait, so this is going to be a U property, so I should have the ability to change those values, just like these values you can see here, inside the blueprint also. So let me add U property macro. Now just to show something, I'll here just leave it as U property and float turn rate equals 45.f, and another u property, float look up rate, that is also 45f. Right, let me compile now. Oh, we have an error. What's the error? Oh, is it because I didn't implement them? Right. That's okay. So I'll add controller your input axis value multiplied by, so here you can see we have multiplied it with base turn rate and get world delta seconds. So base turn rate, wait, why am I not seeing that value? Sorry, I didn't use the base, so yeah, it's okay. Turn rate, and to get delta seconds, get world delta seconds. So that's how we get delta seconds in C++. Similarly, here add control fetch input axis value multiplied by look up rate multiplied by get world get delta seconds. Right. Oh, I have used the same names. That would give us a error. So I'll rename it base turn rate again and base lookup rate. So we have to update at base here. Now the error should be gone, but this is still working. So right, now everything should be fine, but I have to bind these inputs. So here, I'll do it here because this is also relevant to lookup and turn. Let me player input component bind axis text turn rate is addresses EPP the person character turn rate player input component find axis text up, right? This CPP third-person character up, right? Okay, and that should be it. Let me compile. But I don't have I do. Yeah, one more thing. So even though I have added the base turn rate, yeah, it's already visible here. So actually we can do some stuff with this U property. If you make it like now I haven't specified any property specifier, so there are different specifiers for this, like edit defaults only, or blueprint read only, or edit anywhere, things like that. So depending on the specifier you specify here, the capability to edit here may or may not be there. So yeah, right. Now if I test this, now I'm playing, but my right thumbstick inputs are not working. The reason is here the event name is lookup rate, so this turn rate and lookup rate, these are the event names. But in the blueprint also I have the same name, turn rate and lookup rate. And so if I just delete this, it should work. Right, now it is working. Now this is from the controller. Jump is already bound to A. Left thumbstick is for movement and right thumbstick for to look around. Okay, so everything is working as intended. Right, so for example, here you can see base turn rate and base lookup rate, but if you select this instance you don't really see those options. But if I set this property to edit anywhere, I should be able to edit it in the instance itself. Here, now you can see base turn rate also here. Right, and even though if I just use U property and put nothing else here, that also matters because it identifies by the Unreal Engine framework's reflection system, which is important. So things like garbage collection and all those things that happens internally will automatically be associated with this, whatever the properties we are defining here as well. So just remember that. Okay, so I'll make this one also written back. Alright, that's if I make it right, that's you can test with those things. Alright, so I'm gonna stop this episode right here. Now we don't have anything in the blueprint level. Everything is converted to C++ successfully. And thanks for watching. So as always, project files will be available for the download in Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.